Kimberto presents, as part of a project for Sonoma State Geology, a visit to the Lunar Crater Volcanic Field in central Nevada. Please, as a reminder, when you go out into the desert, make sure you have plenty of gas. Also carry extra water. If you get stuck out in the desert, you're going to really wish you had some water. Check your spare, make sure it's okay, and have a workable jack. We leave the Alamo, Nevada area, where we visited some sites of the Alamo Impact event, and we drive north on the extraterrestrial highway, Highway 375. We go past Area 51. Then we head through Rachel, Nevada, where there may or may not be gas. We continue north up to the Lunar Crater Volcanic Field, where we'll see some sights, including the Lunar Crater, the Easy Chair Crater, and the Black Rock Lava Flow. This drive will take a little more than 2 hours. Before we get to the Lunar Crater Volcanic Field, let's discuss, where do volcanoes form? Plate tectonics tells us that Earth's outermost layer, the lithosphere, is broken into large rocky plates, and these plates move. The image on the far left illustrates one plate, an oceanic plate, subducting or going underneath another plate, a continental plate. This is called a convergent plate boundary. As the plates slide past one another, rock melts, turns into magma, and rises, forming volcanoes on the surface. This is what's going on at the Cascade Range in western North America. In the middle image, the two plates are pulling apart, and magma rises between them. This is what occurs in Iceland and is what is known as a divergent plate boundary. The image on the far right shows a hot spot, which is an area in the mantle from which heat rises. This heat rises from deep within the Earth from the core mantle boundary. On the surface, volcanoes form, and this is what's occurring in Hawaii. These are the most common ways in which volcanoes form. It is likely the divergent plate boundary, number 2, plays a role in volcanism at the Lunar Crater Volcanic Field. However, this does not fully explain what is going on there. Here's a map showing volcanic fields in the western U.S. which have been active during the last 2.6 million years or so. The Lunar Crater Volcanic Field is in the middle of the Basin and Range Province and away from the borders of other geologic provinces, which is where most other active areas are located. Evidence suggests that the volcanic activity here is not caused by a hotspot, nor by the normal processes of subduction. One possible explanation for the volcanics at the Lunar Crater Volcanic Field is the theory of slab windows. Basically, a slab window is just a gap in the subducting plate, as shown in the bottom illustration here. This gap alters mantle circulation and melting processes and may lead to magma formation and volcanic activity on the surface. Here we are at the northern end of Highway 375, the extraterrestrial highway. To the left, about 50 miles to the west, is Tonopah, Nevada, and to the right, about 30 miles to the northeast, is the Lunar Crater Volcanic Field. I would set aside a full day to explore the sites here. Remember, there are no services out here, and as usual, bring plenty of water, food, and protection from the sun, especially in the summer, where it can be quite hot out here. Here are some more detailed directions to the Lunar Crater, the Easy Chair Crater, and the Black Rock Lava Flow from the junction of Highway 6 and Highway 375. I did have cell service as long as I was on paved roads, but that fades pretty quickly once you get off the road. The Lunar Crater Volcanic Field is a volcanic field in central Nevada, about 250 miles north of Las Vegas. It's almost 400 square miles. It's 50 miles long by 6 to 12 miles wide. It consists of over 200 vents and other features, including 4 Mars. These are broad, low-relief craters. The Lunar Crater is a Mar. Monogenic volcanoes. These are small, usually single eruption volcanoes. There's various topographic inversion features, like mesas as an example. There's lava flows. These are blocky, jagged lava flows, the kind that are hard to walk on. The is a term from Hawaii. There's also cinder cones. These are steep, conical hills of loose volcanics. Here's a map of the lunar crater area. The heavy red line is the lunar crater backcountry loop. This is a dirt road that might be problematic for some real low clearance vehicles. The most western turnoff to the lunar crater off of Highway 6, the one closest to Tonopah, is not really well marked. The turnoff further to the east is well marked, as is the exit for the Black Rock lava flow. The lunar crater volcanic field is formed on top of older volcanics. The activity for the lunar crater field began about 6 million years ago, and apparently it is decreasing over time and moving northward. The Markath unit is the youngest, about 38,000 years ago. That is the Black Rock lava flow. Here's a photo I took of the lunar crater earlier this year. It's quite impressive in person. It's about 4,000 feet in diameter and about 400 feet deep. It's what is known as a maar. A maar is a type of volcanic crater that tends to be shallow and broad. Please take a careful look at this photo and pay attention to the landmarks highlighted by the arrows. Here's a photo from the mid-60s from NASA. Back in the 60s, NASA used the lunar crater in Nevada to help train their astronauts in preparation for the trips to the moon. A maar is a shallow volcanic crater, usually with steep sides, which is formed by a series of explosions when hot magma comes in contact with groundwater, producing an almost instantaneous violent steam explosion. In Figure A on the left, we see hot magma rising towards the surface. Figure B shows the magma coming in contact with water, causing the first explosion near the surface. Figures C, D, and E, we see repeated explosions which widen and deepen the crater. The diatreme is formed by explosive debris which falls back into it. A diatreme is a volcanic pipe formed by a gaseous explosion. It is typically funnel-shaped, extending downward from the crater floor. When there's no longer water or magma, the growth of the pipe ends. Here is a view of the Easy Chair crater from the dirt road on the way to the lunar crater. This is a cinder cone volcano, which is a different type of volcano than the lunar crater. Topographic inversions are another type of feature common in the lunar crater volcanic field. These inversions, also known as inverted reliefs, are features which have undergone a reversal of elevation relative to other features. Looking at the diagram on the top, a ravine or gully fills with basaltic lava, which then cools. The less erosion-resistant sides erode away, leaving a mesa-type formation with an erosion-resistant cap rock. Plateaus, mesas, and buttes are all examples of topographic inversions. Here are examples of topographic inversions. This photo is taken from the road on the way to the lunar crater. The cap rock is evident on the larger plateau in the background of this picture, and also evident on the smaller isolated mesa in the foreground. The Black Rock lava flow is the youngest flow in the lunar crater volcanic field and is dated to about 38,000 years ago. It is a basaltic flow and is noted for its well-preserved phenocrysts. A phenocryst is a large, distinct crystal surrounded by a finer grained material or matrix. The Black Rock lava flow is a Hawaiian-type eruption. This is a gentle basaltic lava flow where the magma kind of oozes out. This flow is located just off Highway 6 on a very good dirt road. Here's a turnoff from Highway 6 to the Black Rock lava flow. The lava flow is that black area straight ahead. This is the western side of the Markath cinder cone. The Black Rock lava flow erupted from this side. You can see part of the lava flow in the foreground. Here are some specimens from the Black Rock lava flow. On the left, you have plagioclase feldspar crystals. If you want to learn more about feldspars, please watch our video, Sunstone Knoll, Millard County, Utah. And on the right, we have some phenocrysts in rock. We leave the lunar crater area and head west on Highway 6, passing through Tonopah, Nevada, which has plenty of services, gas stations, restaurants, casinos. Then into California and towards the Mono Lake area for the final leg of our 1,100-mile geologic journey. This is about a 4-hour drive in total. Please join us in California to see more volcanic craters, obsidian domes, and the Devil's Postpile. Thanks again for joining us on our adventure to the Lunar Crater Volcanic Field in central Nevada.